Welcome back in this amphitheater for our first workshop now on robots serving field crops. As a reminder, in the meantime, you know there is another workshop in Salle Pastel on robots serving viticulture. You have the program, so you know. You're in the right place. Moderator for this session is Benoit EGON. He's a journalist, editor-in-chief of agricultural machinery section at TERRE-NET, and he will be dealing with this panel. It's a French and English panel, so those who need headset for translation, there's still some available at the entrance. It's all yours, Benoit.
Thank you, Sophie. First of all, I want to just make a small presentation of who am I, because when I speak here last year, I was working as a journalist for TERRE-NET. I always managed this company, but I'm also now with Matériel Agricole, and Matériel Agricole is a magazine dedicated to ag machinery sector in France. Magazine, but also website. But you are not here to hear about me. You are here to hear about robotic in agriculture. I will be animated, as Sophie said, this roundtable. At this roundtable, we will have different people participating. First of all, we will have Ole GREEN, who's the CEO of AGROINTELLI. Then we will have Peter PICKEL, who's the manager of the external relation from John Deere. Because robotic and farming is not only machinery, it's also farming and farmers. We invite today 2 farmers from this region in order to have the attends about robotic in agriculture. First farmer will be Maurice de GUEBRIANT, and the second one will be Olivier CALMETTES. So they will introduce all of them a little bit more further after that. First of all, we are here to speak about robots, and I'm working with Ole GREEN since now some years about, I see all prototypes from your company, and now you've got a finalized product and you begin to sell them. Ole, can you speak a little bit more about what is your robots? And I think you prepared a presentation to give us some business case about farming and robotics. Ole, please come and present us this.
Thank you. And thank you, ladies and gentlemen, for being here today. Having been here at the FIRA for a couple of years, it's a big honor to see how many people really supporting this. Hoping that can give you an insight in our approach in how robotics can serve field crops, so the open arable field farming as our focus. First of all, I'm the founder and CEO of AGROINTELLI. We also have an exhibition, and you're welcome to come by our robot. Beside that, I still have an affiliation with Aarhus University, where I work as a professor with sustainable soil management. The soil management is a crucial part of how we've developed and focused our development on robotics, and that's part of what I will bring you through the presentation. So shortly, I'll divide it into 3 main topics, where the challenges of farming, how I see it, and that's also to discuss that with our farmer panel, and then looking at how robots can serve field crops today. And then look at what is a potential investment case in a specific open field crop. What I would like to show you is some of the challenges that we're facing with robotics today, or in farming today, where robotics can be one of the solutions, is when we're looking across the changing weather conditions. We know how the varying weather gives us more precipitation, we have more drought. A lot of these impacts on how we can actually change our behavior out there is very much where what we are doing as farmers are very much looking into the mechanization. The scope of how we try to develop an automation solution, that was not the scope of developing robotics for agriculture, but looking at how can we make the implements that you know, that you're working with today as farmers, how can we make the implements more self-aware and drive by themselves. So the idea and the scope of our development has been to say, how can we take known implement types and then make them self-driving and more aware of the crops, the soil, and the operation which they're doing. Just jump a couple of slides. So it would, I prepared a small number, some few figures that is taken from Danish farmers, where we last year in November 2018 launched our first platform as an implement carrier, an automated implement carrier. So with this platform, we are able to pull implements, standard implements with up to 3 meter working width. And with these, we have been focusing on a number of intermediate high-value crops for arable farmers like potatoes, sugar beets, to really have that focus where we know the accuracy makes a difference, as well as the business case for applying it, and where we know a lot of work is being spent. So during the summer, spring and summer, we've used robotic for seeding, weeding, and managing spraying in sugar beets from a Danish farmer. If you can just jump over. Something seed, yeah. Good, thank you. I have been through the presentations. One slide just mentioning, which when I saw the Eurostat just a few months back, that now we are an unemployment rate in Europe that is below what we saw back in 2008, which is of course also something that is stressing the farmers as we know it today. Is it actually possible to get people that can help us in practical farming? The other element, when we are looking at some of our fields, this is taken here during the autumn in Denmark, from a maize field, where you can see the maize field here, the soil is not in the best possible condition. And that's where we've been looking at how these threats to our soils can affect also the cropping conditions. So of course, when we drive out there, we need to take care, we need to look at how we affect the soil the least possible way. And of course, when we are compacting soil, there are some significant impacts to our crop production. Especially the yield reduction that comes from lower soil volume for the roots. We have limited water accessibility if the soils are compacted. So these have been some of the elements where we see the automation and robotics as essential in this. And knowing all the companies, and as also was mentioned in the previous presentation, there's so much happening within precision farming, AI, that can help us learning about the arable farming. Peter will also address it from the tractor point of view, and that's where tractors, robotics, whatever, we are looking into an era where sensors on whatever's driving out there is bringing back so much more information. So we can see it could be for disease detection, it could be evaluating what is actually the crop that you're driving on. So using AI to distinguish the crops and the plants out there are some of the new potentials. And either it's being tractors or robotics, they are good carrying platforms. But the good thing about the robotics is that they are not in a rush the same way that some of our drivers may be. And that is part of what I would like to look at when we're looking at how robots can actually serve field crops. And I've taken the anno 2019 to show you some of the examples which we've actually been doing with practical farmers in the Northern Europe today. Roboti is designed as this versatile platform, as mentioned before, where a number of standard implements can be mounted in this frame construction and thereby enable the tool to be self-propelled. It could be in a number of more low-cost, low-valuable operations, but where the accuracy has a huge impact. So neither the robot when seeding, if it's 8-row or 12-row machine or 4-row machine, it's just a matter of the amount of robots we are adding together. One of the essential things here is that we're putting a lot of investment into making a large working width of these implements today, and thereby bringing around a lot of steel to have a high capacity for the manpower spent in the field. When making it smaller, we can make it lighter, and thereby also using much less energy. So looking at how robotics can actually assist us, this is the example from seeding and weeding in maize from an organic maize grower in the western part of Denmark. But where I will actually show you the business case example is from comparing a tractor-based case with a robotic-based case on sugar beet, so seeding, weeding, and spraying in sugar beets, and taking in some assumptions partly from literature and partly from the results that we've seen during this growth season, where we say that for whenever we have the robot working 3 hours in the field, we are spending 1 hour for setting up, for transporting, for servicing and maintaining, because even though the robot is driving by itself, it still have to be greased, it still have to be refueled and refilled with seeds. But we can see as the same implement is being pulled with less iron, we typically see a fuel reduction of plus 10% when we are doing measurements with the same implements. And thereby we've also, for this case, used that for this conventional farmer, by combining band spraying with mechanical weeding, he was able to have also a 62% reduction in his chemicals due to the more high accuracy band spraying that he's been using. So that, as you can see, and I know some of the flat fields here in Denmark is giving good opportunities for a robot to work uniformly over these, and where we have the point that the driver is not getting tired. We may have auto steering on a tractor today, but these systems are helping us to keep the accuracy, and that's of course also what we can utilize on the robot. For the first example, and knowing the rough size of our two farmers, we made a calculation here for a 150 hectare grower that had 150 hectare sugar beets, comparing the investment of his investments with tractors today with what is needed from our robotic point of view to do the same work within the same amount of time, so his working time in the field. I know the PowerPoints will also be made available afterwards, so that's why normally with all these numbers you can see them afterwards. The crucial thing is for us to look at here is, of course, the internal rate of return. So when we do this investment, what is actually the profitability of such an investment? And still, when we're looking at time availability of doing it with a robot, that we can do it sufficiently within the time available, and we can also do it for an investment where we know that this can be done for a lower investment compared to the tractor. Then I know the tractor has so many other abilities where it's usable on the farm. So we are never advocating that the tractors will be retired. Peter was also just mentioning if we are a competitor to the tractors, partly, and that's hopefully what we'll have the chance to discuss now, is also to see this as a supplement, because we still need to transport the robots around. But from our point of view, the important thing is that when working in the field, we need to do this as light as possible to have the least amount of impact on the soil. So the robot investment, of course, can't stand alone. Neither can the tractor, and the tractor can be used for other things. But so can the robot. In our sugar beet farmer in Denmark, there we can also use it for oilseed rape in the autumn, doing the same seeding and weeding operation. In this, talking about the band spraying, is an element that comes in where we can utilize the accuracy of the robotics. So here now showing the numbers of the 300 hectares together with the band spraying. And for the conventional farmer, while having the robot and not needing to do all the work himself, but could let the robot drive around with a high accuracy, that was where he obtained also the savings in chemicals. And as you can see, when the farmer goes bigger, the capacity of the tractor also comes in as being something where we have a payback period that is more comparable between the robot and the tractor-based case as this. But as you will also see in the exhibition, some of the new technologies that we see emerging is also the possibility not only band spraying, but to move the accuracy even further down. So this is from a field demonstration we were doing for farmers in Lelystad in Holland earlier this summer, where we were able to do very precise treatment of potatoes in a sugar beet field, so that we are reducing even further the amount of chemicals. So that is some of the technologies that is so easy to carry around on the robotics. So in short, some of the impacts we see, especially the focus from our point of view and why we believe robotics has its place in farming, is to have the less impact on the soil. And robotics, compared to farmers, may be able to enable the farmers for a more uniform task performance and also to bring back a lot of these automated information from the fields. Thank you.
Thank you, Ole. Please take a seat. Something I forgot just before in the introduction, we will have some presentations in order to know better the people who are speaking over there, and then you will have to ask a question. It will be your job. So not right now, but if you've got questions, don't hesitate to write them down because we will ask you some questions afterwards. For now, I will ask Peter PICKEL to come and present what will be the vision of a big player, a worldwide big player, who's John Deere. Peter is working as a manager of the external relation from John Deere. And we've got a small problem with the presentation because Peter wanted to show us the big booth at Agritechnica. I know it's the right one now. Okay, wonderful. Peter, what is the vision of John Deere about all those stuff on new technology?
Yeah, thank you for the kind introduction. Yeah, I have planned a very short presentation to introduce you to our vision into the future. And when we speak about the future, I want to take you back 1 month earlier. In November, we showed our vision at the Agritechnica fair. And this presentation contains a small video clip about something we did there at the Agritechnica fair for the very, very first time. We have never done it before. We showed things that are not commercially available. We showed the story, our story of the future, in what we called the Future Technology Zone. This was a big area in the middle of our booth, and there were some, I think, marvelous exhibits that could be seen. So I hope the video will work. So this is the Future Technology Zone, and these are just some glances that you can take. The only difference between what you see here and what's actually taking place there is it was quite crowded there. So the animation shows better what you could see at the booth. This was an electric tractor. A robot I will speak about a little bit later. In the background you saw here a cabin which has not a steering wheel but is organized like an office. Drones. In total, you could see 9 exhibits, and here they are. So we showed a fully autonomous electric tractor, an autonomous sprayer looking a little bit like what you saw from Ole from Denmark. We showed a technology we call see and spray. So we have camera-based systems that look onto the ground, onto the crops, distinguish between crops and weeds, and spray a minimum amount of herbicide on the weeds in order to herbicide regulation. We showed 2 types of drones, a large spraying drone with more than 100 kilograms payload in order to do larger spraying tasks. We saw a fleet of small drones with somehow a collecting and recharging station. We showed the command cap. I already mentioned a cap without steering, where the operator can sit in his machine and operate his office jobs rather than to operate the machine. We showed a very small zero-emission compact utility tractor, an auto power transmission, which is really marvelous. It was awarded with the only gold medal as an innovation award on the Agritechnica fair. It is a electric mechanical power split gear with a real important option that we call power offboarding. So it allows to give electric energy to electrified implements through the so-called AEF interface. And finally, last but not least, a semi-autonomous tractor which could go in ring-fenced areas like orchards in an autonomous way, but still having a cap on board. And these exhibits are not so much about, so for us, not so much about robotics. We don't think in robotic terms. It's more they are representing 3 technologies. The first technology is electrification. So we think the future of ag machines is clearly electric. The second technology is artificial intelligence. So we need AI methods in order to do the job on the field optimally. And the last but not least, the third technology field is automation and autonomy. And at John Deere, we call this, what we showed there, our journey from automation, what we have today, to autonomy in the future. So the future is about autonomous machines. And I think the most visionary project that was shown on the Agritechnica fair is this fully autonomous electric tractor. So what you see here is the exhibit shown on our fair. It is a tractor, or more or less a tractor, because it consists out of a rear axle of a tractor, a standard transmission, an adaptation transmission, 2 electric machines, and the 2 tracks that you can see here. What you can not see on this picture are 2 things. We have a new implement interface which allows the system to go for an articulated steering, so a different type of connection of the implement so that you can steer this, if you like to say it or call it a robot. If to steer it, you need an articulated steering. And the second thing refers to the most times asked question about this thing. It is about the battery. Most people coming to our booth and seeing this exhibit, they were crawling down under the tractor and asking, how big is the battery? Where is the battery? There was no battery. So there's one thing that we did not show, how the energy comes into this machine. Why didn't we show it? Because it's not ready. It's just a vision what you see here. But we have some ideas how the energy could come into this machine. So you need an energy supply vehicle. Our idea is, or one of our ideas is to have a vehicle which carries a big cable drum, lays down while it is moving besides this machine, lays down the cable on the ground in the one direction, winds it up in the other direction, and is connected to such a machine via a cable, or to more than just one machine, to a fleet of machines forming a swarm of machines. This is one of the ideas. The other idea is that you could use the energy supply vehicle for different types of machinery. You could power an SPFH, or you could power a combine harvester or other machines on the field. So a slightly new concept about tractors, tractor implement electrification, and tractor robotics, as you might call it. So one of the next steps will be to set up the energy supply vehicle. I will show an idea how it could look like later in a second section roundtable where I'm invited. So this machine shows something very important. It shows an extremely high power density. So what you could see in the machine is a 500 kW machine in the size or running on a tractor axle, which is the same as a 200 horsepower tractor. So power density is enormously increased by electrification. And of course, you do not necessarily have to install 500 kW. This can be scaled down and even upwards. So we think we can cover with such concepts a wide spectrum of power need of ag machines, up to 1 megawatt and more, and down to whatever you need. So this is one of our visions that we had in the future technology zone. And I would not like to make the statement, this is the future. This is just an option for the future. And this will not be a product in the next decade. So let's see what the years starting from 2030 will bring to us. Thank you for your attention.
Thank you, Peter. Please take a seat again. So I will now switch into French. parce que nous allons inviter donc,
because we're going to listen to farmers from the industry. Maurice de GUEBRIANT to begin with. We had a PowerPoint presentation in which you present your farm. Do you want to make your presentation sitting here, or do you want to stand at the rostrum? You have a microphone here, so you can decide to speak directly from there. Good morning. So I'm a farmer in the southwest of France, as Olivier. We're both in the same region, around Toulouse, in the south of France, so in the closest vicinity to this conference center. This is a map where you can see that we are located in the southwest of Toulouse. Now, I work on a farm of 210 hectares. I have one employee, and I recently started on that farm. We are running both a precision conventional farming with a level of modulation, with nitrogen and feeding of plants, which are targeting with those modules. We try to be as accurate as possible with spraying. And we also have some guided devices on most of our vehicles. What is specific in this region is we have a high content of clay, up to 60%. Maybe I was a bit too high, but in some regions we have as much as 60% of clay in the region. And when it comes to topography, we have plains, but also a few plateaux. Now, when it comes to culture, we are changing, we are rotating the crops year in, year out. We are working with durum wheat, and with that we can then manufacture semolina and pasta. Then we also have barley. For brewing, about half is barley, so half is about durum wheat and the rest is barley. And in the spring, of course, we have a lot of sunflowers. This is typical to this region. Also on some of the plants, again for rotation, we have introduced sorghum in the last 4 to 5 years. Also corn, soy, and pretty recently we started with lentils. Which is an interesting type of crop, not very conventional, doesn't have a very good yield in terms of return of investment. Also, thanks to the contraptions I have, we have alfalfa, and we also have, again, spring barley. In the future, I hope to be able to introduce some cover crops. Actually, this farm used to belong to my in-laws, and so we introduced a new type of hoeing, especially for the spring crops. And in the last 4 years, again, as I said, we started to have covering crops or cover crops in order to reduce erosion. This is something which is quite topical in this region. We try to think about the future of our lands, and so we try to avoid erosion. In the future, I think this will be the main danger in this region, and so using cover crops can be a good way to avoid that erosion. So this was the initial system where we would have winter crops and summer crops, and now what we try to transition to is what you can see on the right side, which is also cover crops in the summer and catch crop also, and food crop to again have a better yield, a better return. So I've put a picture here of the different crops that we grow as catch crop or cover crop. That would be probably alfalfa. We've tried also camelin, which is not easy in this region to grow because we do not have enough rain in this region. It's very dry, so it doesn't take so well, and we'll see in the future what the future brings. Thank you, Maurice. Olivier, can you also make a short presentation of your farm? Well, good morning, everybody. Well, I'm also a farmer in the same region, so in the Lauragais region, so very close to here, very close to Toulouse. I have 71 hectares and I work by myself. This is a family farm which belonged to my father and to his father before him, so I'm the fourth generation of farmer on that farm. The farm has grown. In the past, my grandfather didn't have that big of a farm, so it's grown very substantially. I work, so Maurice said that he has a number of plains, while I have many hills and slopes. So we're not discussing a very high slope, but still, it's a very hilly sort of plot. I mostly grow durum wheat and also sunflowers. Sunflower. I have what we called a managed crop. I hoe the majority of the plot, about 50% I have summer crops and about half, the other half is winter crop. Can you tell us more about the technologies and machines? When we prepared this roundtable, you said that you increased precision. Well, yes, I'm trying to be more precise, especially when it comes to the use of fertilizers. I only started very recently, so I cannot look back to many years. I started last year, so about 12 months. So I need to, I suppose, to implement that type of precision fertilizing for a longer period of time to be able to provide you with some feedback. But I started with durum wheat, and I have a more homogeneous crop now that I have this precision, because in some places we used to spray too much, and in some areas we would spray too little. Now, thanks to this precision modulated spraying, we are more accurate, and therefore this is more homogeneous in the output. Now, if we were to really start with the topic of his roundtable, Olivier, you do not have a robot, right? So you discover both robots. You've been hardly discovering that this morning. Well, this is what you can say. You say, I'm not familiar with the industry. Now, what are your expectations with robots? What are your fears? What are the objectives that you set for yourself and for your farm with robots? Well, yeah, I have to admit that when you asked me to come to this roundtable, I didn't think much about it. Now, of course, when you asked me to come, and in the meantime I've read quite a bit and I've been thinking. Now, of course, modelization and precision spraying is just the beginning, it's just the tip of the iceberg for me. But I do see that there are beautiful contraptions and devices out there. Now, is it something that can be widespread and disseminated to all types of farms, all types of topography, especially hillside farms? I'm not sure. But again, if I talk about my own farm, the weather is pretty complex at the moment. We have a lot of rain, and so we have a hard time with our farm at the moment, especially to seed, because of that much rain. And so I was wondering whether robots could help us seed, especially when it rains so much as it did in the last 10 days or so. So this was part of my questions. Maybe it could help when we have those extreme weather conditions. Now, when it comes to phytosanitary products and spraying, this is a topic, of course, which is very important for us. And so I was wondering whether those robots could help, and instead of spraying the plants, maybe we could have a weeding contraption, a weeding device that could weed the unwanted plants, so as to avoid or reduce the use of phytosanitary products. And that way we would have cleaner crops by having this mechanical treatment.
Microphone is just over there. Peter, Ole, who want to?
Yeah, long question. My answer is, so the robot is just an actuator in a larger So my question is, the robot is just an actuator in a larger automation system in the farm. And the goal is using the robot, the vision of that we are after, that we are working for, is to treat each plant on the field as an individual. And bring to the plant, to this individuum, what it needs and exactly what it needs. This means the minimum amount of plant protection chemicals. That's a task a robot can do, or autonomous machines can do. The minimum but optimal amount of fertilizer to bring to this individual in order to bring the maximum yield. That's what we want to do. And of course, water is also an aspect. If you have irrigation, we want to bring exactly the amount of water that the plant needs to the specific specific date in the year. So these are the goals, and as I said, the robots are the actuators in the field. In wet conditions, you can take a set of measures in order to decrease your problems. A robot with a low weight could be a measure that you could undertake in order to improve your problem with trafficability of your soil. That would be one of the measures. Other measures are taking more driven wheels. So I did not explain it in my presentation, but the e-auto power drivetrain with the power offboarding allows for powering electric implements. The electric implement could be, for example, a trailer, a slurry trailer, and you can power, that's what we showed, the axles. So making out of a 4-wheel drive tractor an 8-wheel drive tractor implement system. This can be done, and there are a lot of pleasures. This is measures. This is just a step, an incremental step. Finally, we will have systems of tractors, implements, robots and implements, whatever you can imagine, that solve these problems. But you will have to wait some years still.
Ole, perhaps a compliment on this?
Yes. First of all, you don't have to wait a couple of years. I think there are solutions on the way, and I think especially the element of trafficability is where, when we are looking at the machines driving on our fields today, when we have a person, we have been trying for the last 30, 40 years to optimize how much work can be done by one person in an hour, so the efficiency per work hour. As soon as we can remove the person from sitting on top of the machine, we can basically cut the machine into pieces, utilizing the same technology as we're doing today. And that is where I see the robotization coming in, because we don't need 9-meter working widths to, for an example, have a high capacity. We can have 3 times 3 meter, thereby having lighter machines with better possibilities for trafficability. I know that there are the Orchard robot also from John Deere. So the element of using smaller, so as soon as you don't have to sit on top of it, the calculation of your investment changes. And I think that's the huge element that robotics brings into our business case, is we are used to thinking about the capacity based on we are sitting on top of the implement. But as soon as we are looking at it, we can look at 1 robot or we can look at 5 robots, and thereby also enabling smaller farms, also the accessibility to new technologies, rather than that you have to have a big farm to be able to carry the cost of the investment in modern technology.
Thank you, Ole. Maurice, est-ce que tu peux aussi nous faire un petit...
Maurice, can you give us also an overview of your expectations, your fears, the objectives that you have for your farm?
Ce sera mieux que le micro, ouais.
Better with a mic. Well, yes, you'll hear me better if I use a microphone. It's a very, very wide question. My main objective is to be more precise, and therefore the question you gave Olivier just right now, to be able to put fertilizer at the very bottom of the plant and be able to weed and to be able to take care of the plants that need it, and to be able to work individually, if you want, as you said earlier, or differentiating things. This is the advantage of a robot, and if it's properly programmed, then you can work on its own. You can rest a while and just check if there's a problem. It's like for milking, you know. I come from a region originally where there's a lot of milking, so you're teasing for the next round table and in the other room on breeding. Yes, well, these are devices that work very well, so it's probably repeatable for cultivation. So why shouldn't the robot work on its own? And if there's a problem, there's a warning that wakes you up, and you can add some fuel if it needs fuel, or battery, or add seeds, or fertilizer. To me, it's important if you want to gain more precision. And coming back to what I said earlier, in my opinion, it can be a very good performing tool. I like the caterpillars of the John Deere robot. We were talking about wet soil at present. It's important if you can go to a wet soil and have less compaction and be able to do some operations in more wet weather, which you can't do with a tractor. Even if you use caterpillars, if your tractor is 20 tons, it's going to damage the soil in a way. So I didn't take note, but I liked what you said earlier when you said it wasn't a replacement for the tractor or the farmer. It's just an added value for the farm. And we do have tools that work very well. For example, some things can't be used with a plow, can't be used with a robot, but you can replace some things. For example, for the wheat at the end of the winter, you have problem with grass, so maybe we have some wheat that come back every 2 years. Maybe a very light robot at the end of the winter could be very interesting. I don't know how. Well, we'll have workshops later on.
With all the audience. You wanted just to give an answer to Maurice? Go on. And then we begin the question and answers.
Yes, thank you. I had to comment on, I think, with the caterpillar, so using belts, because I think it's rather interesting to look at how many robots today is presented without belts. And when we look at the power consumption, I think that's an interesting aspect that we are looking at. Typically, pulling the same implement, we are spending more energy in moving a belt around. So if we have a lighter machine, I think there are also elements or ways how we can reduce the total energy consumption, which I think will be an important criteria to be able to continue farming in Europe when we're looking at our sustainability. So I think that's interesting to see that belts is not a need to have if we can have it lightweight enough. I think a lot of the robots actually should demonstrate that today.
The best way to reduce energy consumption is to go for electric drives. So this is, I think, agreed upon. And the second measure that you can take is reducing the slip. And there are different measures that you can do. So I already explained them. Going from 4-wheel drive to 8-wheel drive, this will be available in latest 2 years from now on from our company. Going to tracks is a measure to reduce the slip and increases the energy efficiency. And going to lighter vehicles is also a good measure, so long as you don't need the traction force. If you need high traction, then you need a certain weight of the machine, otherwise you cannot generate the power, the force that you need to pull the implement. You can replace the implement by milling machines or mechanically driven machines, implements, but this in many cases is not efficient with regard to energy supply for other reasons, for soil-related reasons.
Thank you, Peter. And now, guys, it's your turn. Maintenant, c'est votre tour. If you've got some questions to the people who are sitting right in front of you, I think there are some microphones. If somebody can distribute a microphone. Is there a question in the room? I go in front because I've got the light in the eyes.
We have a 15 minutes session of questions and answers, so take your time.
I've got 2 questions over there. Is there somebody
I'll
with
bring
a
the
microphone?
microphone.
Alors, où êtes-vous pour les questions? J'arrive.
Where are you? Let me give you a mic.
Les prochaines seront des drones qui apporteront les micros.
Next year it will be a drone bringing you the mic.
C'est une bonne idée, ça.
That's a good idea.
Yeah, good morning. I mean, 2 quick questions related to fuel efficiency. Only in your slide, I mean, you mentioned that robots were 10% more efficient in terms of energy or fuel. Is it related, I mean, to the difference of technology or simply difference between fuel and electricity as a source of energy?
The specific comparisons that we've had made by the Danish Technological Institute was measuring on the same implement, but simply the fact that you're moving less steel around in the field, so that the point that Peter mentioned, that you need a certain weight for a certain to transfer the energy to the field. But the way we've designed the robot so that we're using the implement's weight basically also on top of the wheels. So we see that we try to create a more balanced system, and therefore we can have less total steel in the field per work meter. And thereby we can see that we are spending less energy for the comparison for pulling the same implement. So it's been based on in a diesel experiment for both a tractor versus a robot.
Okay, so go ahead, Peter.
I would like to add something. The amount of steel you carry over the field is not extremely important for agricultural machines, because we do not so much accelerate and decelerate the machines. So this amount of energy does not play the major role. The most important role is what you do in the soil. So the soil resistance, if you are doing soil tillage, this is the major issue. And there's a physical law behind it that says that the energy consumption increases with power 3 of the speed, and it increases with proportionally to the working width. This means you have to create or pull, at least if you're talking about soil tillage, which is the most energy consuming work that you can do on the field, we have to increase the working width rather than increasing the working speed. So this is my plaidoyer, and I believe you can do it with big implements, and therefore you need some weight on the machines to create the traction force. Otherwise, it will not work. This is a physical law.
Okay, thank you. Maybe shortly the second question. I mean, keep the mic because it's for you. You mentioned that the future of the industry or this agriculture is in electricity. Do you foresee a very rapid change like it's happening right now in the automotive industry?
No, we are behind the automotive industry as always, I would like to say. But we have started with the e-auto power drive, with the power offboarding, I think, or we believe that we have given a spark that could be an initiating point or, for more electrification. So we believe in electrification, and we hope that with the introduction of the e-auto power transmission, before the next Agritechnica, we will initiate a lot of electric development on the implement side. And we hope that with this development, with this trend which hopefully will take place, we will initiate electrification. And something like electromobility, I don't see it coming up with high numbers of machines before 2030. So I would say we are behind the automotive industry.
Question.
Question in the middle of the room from Davide Rizzo.
Unilassal, nice to meet you. It's very good to have farmers and machine constructor and manufacturer. What do you think will be the main challenge for tackling new cropping systems? I mean, Olivier presented a strong evolution of his cropping systems. We are focusing on phytochemicals, soil management, but what about the overall farm management from the point of view of farming robots?
If we're looking at the general development in farm management systems, there's no doubt that the accessibility of data is increasing, and we see systems also from John Deere where the data management will be an important part of future farming. But I think that is not directly linked to the robotics. The robotics or the modern tractor with all the sensors or a combiner today are supplying us with a huge amount of data where we are basically lacking a lot of the tools really to comprehend the information hidden in the data, because the farmers don't like to see a lot of tables. We like to see something that has been treated. So I think that's also one of the challenges we're facing in farming. We need to be able to transform the data into something informative. And I think what John Deere showed at also their future farming booth with the new cap is really how can we utilize some of the new technologies for making information easy accessible as a human for us. We are very visual, and I think that's part of how we need to look at this. But that's where, as a lot of the small companies exhibiting here with the robots, we are part of the puzzle. This is something that has to play together, where open data standards is of course an essential part of that.
I would fully agree, but I would like to add something. I think personally, the biggest challenge that we are facing is to keep up the competitiveness of the local farmers with the farmers from abroad, because those farmers are not competing against each other. They are competing with farmers located in CIS countries and in other parts of the world. And I think this is more a social and a political problem than a technology problem. From the technology point of view, the data management, creating information out of data, handling and treating this information accurately and safely is certainly a big problem, and perhaps the biggest problem of our current technology developments. But I think the social and political problems are much bigger.
Une autre question dans la salle.
J'avais juste
another question in the room.
Par rapport à la gestion des données.
Yes, talking about data management and robot management also, because we didn't mention it. Basically, we're farmers. Olivier said he took over a family farm. I guess that initially he learned to manage the operations, to build, to drive a tractor, to pick the crops, etc. And progressively he's added a console in the tractor to manage the fertilization. Then he gets another console for the GPS that is going to pilot the seeding or the fertilizing machine, and and then you ask him how you want him to you want these data to be analyzed. So it's a problem, because you start from someone who was putting seeds in the soil, and he has to end up being a banker, computer expert, financier, and maybe an engineer, because very soon we'll have to learn how to work differently and to organize the plant cover. So it's part of the joy of our work, because more and more we look at lots of different things. But it's true that I'm quite young in this field and I'm interested in computer science, but it's not always easy, even with John Deere, because I have a John Deere tool with a GPS that's quite easy to use, user-friendly. But even those who are supposed to be user-friendly, sometimes it's difficult for us to use them to implement them. Sometimes the satellite is not working or a satellite connection. So I didn't say it in the beginning because I didn't think of it. But this is also a true key for success when you talk about robotics in agriculture. You have to have tools that are user-friendly, easy to use, and you have to train the people who have to use them, because basically that's not our training. We're not computer experts.
Yes, Maurice.
Thank you, Maurice. And one last question from the room. You have the mic, sir. Go ahead.
My name is Ricard Pardell. I am CEO at Earth Rover. And the question is for Peter. Haven't you considered using hydrogen for the electrification of the tractors?
Yes, we do have, and currently we don't believe in hydrogen or fuel cells so much. We are still investigating it a little bit, but our confidence that this technology will be the solution of the energy storage problem of batteries is very low. The reason is that the fuel cell has severe problems with integration, packaging onto an agricultural machine, very similar to the problems battery have. And if we don't see, we are not battery producers, we are not fuel cell producers, but we see the fuel cell very, very similar as a battery. So what we are producing is our electric drivetrains. If somebody comes up with a fuel cell solving the problems of the past, allowing us for packaging it with a good energy storage capacity into a machine, we will just throw out the batteries out of our minds and replace it by fuel cells. But currently, the technology jump, the leap is not in sight.
Thank you, Peter. Thank you for all the participants. I think they need some applause because it's not easy. So please, for them. It will be now the end of this roundtable, but it's just the beginning of FIRA, and you will have plenty of time in order to ask questions directly to them during the coffee breaks and so on. So thanks a lot again. And